The hardest part about doing these problems is interpreting it. And I walked around, I saw multiple different ways of how you guys chose to interpret it and write about it. And so a lot of them, like, even though there's 3 different ways out there, they weren't incorrect. They were correct. Okay, you just got to be careful and make sure you understand all around the problem. Now check this out. This is one that I saw. You drew it, and you have X right here and Y right here, and then I should probably read the problem, just because I'm starting out here. A window is being built, and the bottom is a rectangle, and the top is a semicircle. There's our picture. You would have, if you're trying to just read this, interpret it, underline those because they're math words. You guys pay special attention to those, and numbers. If there's 12 meters of framing material, what must be the area, there's another one, of the window to let the most light in? So we're trying to optimize that. Some people like to box what they're going to optimize. That's just up to you. I'm going to go ahead and leave it there. So then you probably thought, okay, well, I need an area function. And most of you guys tried to make an area function, which was phenomenal. That's awesome. But look at what you guys did. You said first, well, I got the rectangle, so that's x times y. That's great. That's correct. Then you said, I also have that semicircle. And so I have 1/2 pi r squared. And now this is correct, but you're adding an extra variable that you don't need to. R is what? R is right here. That's your radius, right? So why put an R there? Why not put half of x? Okay, instead of putting an R there, you could say 1/2 x squared. Now that's one way to see it. I was looking at other pictures, and what some students did is they had the R there first. And so instead of having the x right here, they put 2r. And so now you got rid of the x. So it doesn't matter which way you do it, just as long as you only have 2 variables with the a. So right now we have 1, 2, 3, 4 variables. Nah. We need to get rid of either this x or this r. And I think I'm going to get rid of the x. The last time I saw this, I got rid of the r. But I kind of like the way this is set up, because now I don't have to square anything weird right here. So I'm going to take out this x and put a 2r there instead. I kind of like that. I think that's what another student was trying to tell me last period, and I didn't understand what they were saying. But anyways, someone else drew a nice picture. I saw it really fast and was, oh yeah, that's a good idea. So that right there, that a, that's what we're trying to optimize. So that means that is what you're going to be taking the derivative of. But remember, when you take the derivative, you're taking the derivative with respect to something. And you don't want it to be, you don't want to have 2 variables here. We have an r and a y. We want to take the derivative with respect to just the r or just the y. So, is there another equation that we can create in this problem that relates the r and the y together? Now, you should have been thinking like, oh, that 12. There's a 12 right there, and I haven't used that number at all. Is there a way I can use that number? Yes, there is. If this is the framing, that's going to be all the way around the window. Now, in all honesty, I think this problem should have been more specific about that, because when you're thinking about constructing a window, maybe you're thinking that there needs to be a support right here. I don't know what you guys know about windows or what windows you've seen. I don't know, but it's just talking about the perimeter of the window. So we have 12 equals, we have 2y's plus the 2r, right? Because we have this y right here, this y right here, plus the 2r, and then we have this right here. Now, how do we do that? How do we add that? Well, how do you find the perimeter of a circle? Yeah, 2 pi r. That's pi times diameter, or 2 r's times pi. That's the circumference, but it's just half of it, right? It's not the whole circumference, just half the circumference. So we have 1/2 times 2 pi r, because our radius is just r. Oh, cool. And that 2 and the 1/2 cancel out, so we get a little simpler looking problem. So we have 12 equals 2y plus 2r plus pi r. Okay, so we have an equation right here, and we have an equation right here. I want to use that second one to get rid of, to replace either the r or the y here. Which one do you guys want to solve for in this equation? You want to solve for the y or for the r? Solve for the y? Okay. So we'll solve for the y down there, and let's see what we get. Let's move the r's to the other side. So we'll have 12 minus 2r minus pi r. And then on the other side, we'll have our 2y. So I just subtracted these and put them over there with the 12, which is why they're both subtracting right here from the 12. And then divide everything by 2. So I have y equals 6 minus r minus 1/2, or we can say pi over 2r. There's different ways to write it. Doesn't mean your way is wrong. Okay. So let's plug that in and see what our new area equation looks like. We have a equals, we're taking out that y, so we're going to say 2r times y, and our y is 6 minus r minus pi over 2r. And then, oh cool, no more substitution, just plus, we're going to say pi over 2r squared. Alright. So we want to take the derivative of that. Now, if I'm going to take the derivative of that, I probably do want to simplify that just a little bit more. So I get 12r minus 2r squared minus pi r squared plus pi over 2r squared. Now, usually what you try to do next is you try to combine like terms, which we actually have some like terms. This is like, this is like, this like. Those are all like terms. But I'm going to leave them the way they are right now and just take the derivative of it the way it stands. Let's see. So we got, I'm going to take the derivative. We get 12 minus 4r minus 2 pi r plus pi r. All right. Now what do we do with that? What do we do with our derivative? Why are we even trying to find the derivative? Okay, I wanted to stop right here because there's a lot of math that we just did, and sometimes we get lost in what we're doing and forget our end goal. So if we stop for a second and go, okay, wait a second, what are we doing? I want to make sure I'm making the correct steps forward. You would reread this and go, okay, I'm trying to maximize the area. What is this right here? That's an equation. Actually, now it's a function because we only have one variable over here. It's a function for the area. And just to help you guys see where we're going, if I were to graph that, which I know you guys just did, you plug it in like so. You have to use X in your calculator. That's in place of the R, and then you hit graph. I don't know what my window is going to look like. Hopefully it fits. Oh yeah. Oh, that's not bad. That's not bad at all. Okay, so that fits. This is a standard window. We're looking for that right there. That max area. We want to know that max area. So, if we didn't have a graphing calculator, what we could do is we can use a derivative to find where the slope of 0 is. Because what's the slope at a max? 0. So, knowing that, using that, we're going to set this equal to 0. This is how we're going to do it. We're going to set that equal to 0. And then we have this nasty thing right here. And then we're solving for r. Now r is, there's no r squared. And this guy right here, this guy right here, and this guy right here, these are actually like terms. So can I combine them? No fractions, which is nice. Actually, I can combine these two very simply. I have 1 pi r there and negative 2 pi r. So now I really have 12 minus 4r minus pi r, minus 1 pi r. And then if I'm trying to get the r alone, I want to factor an r out of those so I can get the r alone. Okay, so let's first get this 12 over here. I take an r out. I have negative 4 minus pi. I divide both sides by the minus 4 minus pi. So those go away. And this side, I divide it by minus 4 minus pi. And I got my number. Now I could take a negative out of the bottom, and I could take a negative out of the top, so I'm going to make these all positive. So now we have r equals 12 over 4 plus pi. That's kind of a nasty looking number, but I'm not using a calculator or anything, so this is what I would have to use. if I plug that into a calculator, let's see, what would you get? Can you guys try that in your calculator? Make sure you use parentheses for the 4 plus r. So you would say 12 divided by, and then in parentheses, 4 plus pi. Still have not found the max area. We found r. We found the radius. That's this guy. Okay, how am I going to find the max area? You're going to take this r, and you're going to plug it back into this a. Now, is it max? No. We need the r to find the max area. Now, you could also take this r and plug it into this over here and find your y, then take the y and the r and do something else. That sounds really complicated, though.
Wait, the r is the max, though, right?
R is where the max is. Yeah. So here, check this out. That's 12 divided by 4 plus pi. So when I plug this in my calculator, I get 1.68. Go back to the graph. You can say second calc max. Put a left bound, something to the left side of this max, which is 0. Or any number to the left side of it, and then something to the right side. I know that my tick marks are counting by 1, so I can do 3 right here. So this is 3. Then guess. Hopefully I get 1.68. Oh, I did. Cool. There you have it. And actually your calculator gives you your area also. So when you plug your answer into this guy right here, you should get that same answer, this guy. Yeah, so that's your area. The area is 10 point something. Yeah. So this is what it would look like if you plugged in that R. It's pretty nasty. Okay. Almost guarantee you, like, a regular problem wouldn't expect you to do all that. It would give you a calculator option. You could use a calculator to finish it. If I started this, I probably would have stopped, and I probably would have taken this R and plugged it into this right here, because I only have to plug it in twice, and solve for y, and then plug the y and the r into this. I don't know, like, that might have been more simple, I don't know. I would have really hoped that this would be a calculator problem, and I'm almost 100% sure it would have been.